We're going to talk about how to do elimination. Our goal is the same. We have two equations. They each have two variables. That means I can't figure out what x or y is. But if I take the two equations together, I can get down to just one equation with one variable. And then we're actually able to solve it. So our goal this time, I want to be able to add straight down. So I want to add these two x terms, add the two y terms, and have one of those variables cancel out. So you can pick either one. In this case, I see that this y right here doesn't have a number in front of it, so that means it's just a 1. That tends to be the easier one to try to eliminate. Right here, this is negative 3y. If I want these guys to add up and cancel out, that means I want this number to be positive 3y. So I'm going to multiply this whole bottom equation by something to make it positive 3y. Right now it's 1y, so that means I have to multiply by positive 3 to make that happen. I'm going to take that top equation and just rewrite it. And then that bottom equation, I'm going to take every single term and multiply by 3. So I'll get negative 6x plus 3y equals negative 30. Now when I look, I have negative 3y and positive 3y. Same number, opposite sign. So I know when I add these guys up, they will cancel out. So we're going to think of this as an addition problem. I'm going to add straight down. 4x plus negative 6x is negative 2x. Negative 3y plus 3y is 0, so I just canceled out one of the variables. And then positive 22 plus negative 30 is negative 8. And now I'm down to one variable, and I can actually solve for that variable. So in this case, we'll get x equals 4. Remember though that you're not done. You have to plug in that x equals 4 into one of those equations. Doesn't matter, you could pick one of the original ones over here, or you could pick the new one. Doesn't matter. I'm going to pick that bottom equation. So negative 2 times x, which we just figured out is 4, plus y equals negative 10. And then I have to add 8 to each side to get y by itself, and I get y equals negative 2. So these two lines, if I were to graph them, would meet at the point 4, negative 2. So here's another example of elimination. This time when I look at the numbers in front of each variable, I don't see one that has a 1 in front of it. So in this case, there's not one that's necessarily easier than the other one. So I'm going to cancel out the x's. I have positive 3x and positive 2x here. I know 3 and 2 both go into 6. So I want one of these to be positive 6 and one of these to be negative 6. So if I multiply this top equation by 2, right here, 2 times 3x, that'll give me positive 6. That means I want this bottom x value to be negative 6. So I'm going to have to multiply that by negative 3. Now, if you notice, really what I did, I took this value right there and I brought it down. I took this value and brought it up, but I did have to change the sign right here to make sure one of the numbers is going to become positive, the other one's negative. So multiply that whole top equation by 2, 6x minus 12y equals negative 6. And then we're going to take that whole bottom equation and multiply it by negative 3. And here's what you get. Now when I add these guys up, notice I have positive 6x and negative 6x, so those guys cancel each other out. Negative 12y plus 12, or plus negative 12y is negative 24y. And then we have negative 6 plus negative 90 is negative 96. Divide both sides by negative 24. And we'll figure out y is 4. Remember, you're not done. We have to plug that back in to figure out what x is. Does not matter which equation. I'm going to pick that bottom one. So 2x plus 4 times 4 equals 30. I need to subtract 16 from each side. So we get 2x equals 14. Divide both sides by 2. We get x equals 7. So in this case, if we were to graph these two lines, they would cross at the point 7, 4. Here's one more example of elimination. So I look at, I'm going to look at the y's because those numbers are a little bit smaller. And I see this is 2y and this is negative 6y. I know I can multiply this top number by 3 and make that positive 6y. So when I add it to negative 6y, I'll get 0. So I'm going to take this whole top equation and multiply by positive 3. And that'll give positive 6 on top. So remember, you have to multiply every single term. So you'll get 21x plus 6y equals 24. The other equation we didn't have to do anything to, so I'm just going to recopy it right underneath. And now we can change this into an addition problem. We're going to add straight down. So positive 21x plus negative 21x is 0, so that cancels out. Positive 6y plus negative 6y is 0, so that cancels out. So on the left-hand side of the equation, we have 0, and then the equal sign, and on the right, 24 plus 10 is 34. So when this happens, we cancel out both variables, and we ended up with a statement that is false. So 0 does not actually equal 34. Your answer is no solution. That means these lines are actually parallel to each other, so they never cross, which means there's no point that would work in both equations. If you got something, like let's say your answer was 0 equals 0 after you added the two equations together, then your answer would be infinite numbers of solutions, because that means the two lines are actually the same.